Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. So today, my group 4, will present our assignment 2. So we have team members of 4. So our today's agenda consists of 4 items. Number 1 is the background of the total productive maintenance. Number 2, discussion and justification on total productive maintenance pillars. Number 3, discussion and justification on OEE. And the last one, study case example. So next slide. So let me explain my story, the background of total productive maintenance. Total productive maintenance originated in Japan during 1960s as a methodology aimed at maximizing equipment effectiveness and eliminating production losses. Its development was closely linked to the evolution of maintenance practice in manufacturing industries, particularly in response to the challenge posed by increasingly complex machinery and competitive market demands. So the next slide. So let me story the key milestone from 1950s until 1980s. So around 1950, after World War II, Japan manufacturing industry faced a need of efficient production to reboot its economy. Preventive maintenance concepts were borrowed from the US, focusing on scheduled maintenance to avoid equipment breakdown. On 1960s, introduction of the maintenance by Nippon Denso, supplier to Toyota, to introduce productive maintenance to ensure equipment was always in good condition, enhancing its productivity. On 1970s, Shichi Nakajima, considered the father of TPM, formalized the concept by integrating maintenance with company-wide productivity improvement goals. TPM expanded the scope to include all employees from top management to shop floor operators, aiming for zero defect, zero breakdown, zero accident. The Japan Institute of Plant Maintenance (JIPM) played a significant role in promoting and standardizing the TPM. On 1980s, the success of TPM in Japan caught the attention of manufacturers worldwide. Multinational companies began adopting TPM principles to improve operation efficiency, especially in automotive, electronic, and consumer goods industry. So next, the pillars of TPM. I will pass to my next member. Thank you.
Hello to all the viewers, I'm Ng Sije. I will be presenting on the pillar of Total Productive Maintenance, TPM. The early version of TPM was introduced in 5S method. This is a method that includes sort, set in order, shine, standardize, and sustain. After incorporating with 5S method, the 8 pillars was developed to improve the productivity through workforce empowerment by focusing on the proactive and preventive maintenance shown below, and the objective final goals is to achieve zero failure, zero defects, and zero accident, and etc. Let's briefly describe each pillars. The first pillar is autonomous maintenance. These pillars focus on the operator's responsibility, daily preventive maintenance, and enhance the reliability on the equipment. Second, process and machine improvement. This pillar focus on process efficiency by form of a small team to reduce wastage. So third is preventive maintenance. These pillars is to predict the failure rates, plan for the maintenance, and aim to extend the equipment life. Fourth is the early equipment management. These pillars focus on understanding the equipment issues, involvement of the users prior to installation, and aims to design for reliability. The fifth pillar is the process quality management. This pillar determines the error, minimize defects, and ensure proper history records of the root cause analysis has been recorded. Six is the administrative work. These pillars focus on resource allocation. It heavily involved with the user for better understanding and reduce the waste. 7, which is the education and training. These pillars enhance employee skills, build self-confidence, and ultimately reduce errors during the process. The final pillars is the safety and sustained success. Aim for workplace safety, business compliance, and eliminates potential risks. The total productive maintenance program should be specific, aligned to the company needs and circumstances. This section provides the guidance to execute TPM programs in a company. First, define the issues and set goals. Second, establish TPM community with cross-function representatives. Third, provide trainings and create awareness to engage with the team. Fourth, develop and implement action plan such as pilot project based on criticality. Fifth, implement TPM pillars systematically. Address objectives while involving employees at all levels. Sixth, tracks program and continue feedback for readjustment. 7. Sustain TPM practice. Next, I will pass the OEE presentation to my friend Mr. Yong. Thank you.
Hi everyone, I'm Yong and I will continue to briefing the OEE. So the OEE actually stands for Overall Equipment Effectiveness. It is a lean tools and metrics. It can reflect the effectiveness of production equipment or machine in the manufacturing time. Measuring OEE will provide a useful insight about the performance of production process and how to methodically enhance the process efficiency. So the OEE index is multiplied by 3 factors in percentage, which is availability, performance, and quality. Let me further explain how to calculate the 3 factors. So first factor is availability. Availability is to measure the percentage of equipment available operating time in planner schedule. The formula is runtime divided by planner production time. So the runtime is actual machine operating hours during the shift. It is exclude the unplanned downtime. The unplanned downtime is unpredicted incident cause the production or machine stop running. For example, machine breakdown, minor stop, model changeover, set up machine tools, or material shortage issue. So the planner production time was being planned and scheduled in advance for the manufacturing running hours. For example, we consider one production shift is 12 hours and total production break time in one shift is 1.5 hours, and planner have planned the maintenance schedule is 0.5 hours. So total planned downtime will be 2 hours. So 12 hours deduct 2 hours, the balance 10 hours will be planner production time. So the second factor is performance. Performance is to evaluate how well the machine operates when it is running. It used to check the machine is it running in the right speed. The formula of performance is ideal cycle time times total count divided by runtime. So ideal cycle time is how fast one piece part can be produced. Ideal cycle time will be either minute per unit or hour per unit. It is depend on the runtime is minute or hours. The total count means the total number of part has produced during the shift. The total number including the good part quantity and bad part quantity. So the last factor is quality. Quality is to measure the ratio of good part quantity versus total count quantity. The quality factor is to identify the machine or equipment is producing the good part. The good count means that the part is one-time pass without any rework, defect, or reprocess. So after we count the OEE percentage, how to consider the value is good or bad? In the OEE score benchmark, above 85% is world-class OEE. At 60% OEE is typical percentage in majority industry. Therefore, company could base on the OEE value to implement Kaizen activity in specific session to improve the OEE score. For those the score below than 40%, it is uncommon manufacturing process and it has a lot of easy improvement can be done to significantly to increase the OEE score. I will hand over the speak to the next team member. Thank you.
Welcome and hi all, my name is Dayan Nurhan. I'll represent Team 6 to share with you two case studies mainly on total productive maintenance TPM at Malaysia Airlines, and the second one, the implementation of overall equipment effectiveness OEE implementation at ABB. So let's look at the first case study at Malaysia Airlines. Malaysia Airlines is our national carrier, which has a rich history dated back to over 50 years, evolving from a government agency then privatized as a prominent corporate entity in Malaysia. It has approximately 110 aircraft flying across 6 continents to over 100 cities in the world. In the recent years, we have heard that Malaysia Airlines face a lot of challenges. Amongst others are the first economic and industrial crisis, such as Asian financial crisis, second global events like 9/11 attacks, SARS outbreak, and a rising fuel cost which has severely impacted the aviation sector. Third, competition from low-cost carriers LCC. Fourth, operational inefficiencies due to high maintenance costs and aging fleets. Fifth, brand crisis, tragedies like disappearance of flight MH370 and MH17 incident has significantly affected public perception and business operations. And lastly, on technological and market evolution, whereby rapid technological advancements require high investment to stay competitive. Malaysia Airlines has adopted TPM, which aligns with the need to reduce downtime, optimize maintenance costs, and ensure passenger safety. The method has steered Malaysia Airlines to its recovery and continued growth amidst industry challenges. They have introduced policies and strategic approaches such as maintenance efficiency and downtime reduction through a program named Maintenance Efficiency System (MES) to minimize aircraft maintenance downtime, optimize hangar slot management, and enhance the tracking of engines and assemblies. Second, aging aircraft and corrosion prevention. corrosion prevention programs and upgrades for aging aircraft, maintain reliability and prolong the lifespan of assets. Third, deployment of expertise and specialization in maintenance, where established expertise in managing large fleets such as B737, showcasing its capabilities in maintenance and operational efficiency. Fourth, technology integration in maintenance that reflects a commitment to integrate innovation into maintenance processes, leveraging advanced technology for better asset utilization and continuous improvement in modernizing its fleet and upgrading the facilities. Next is on cost efficiency through alliances. Malaysia Airlines introduced code-sharing agreements with other airlines while maintaining maintenance autonomy, allowing effective operational cost distribution without compromising its quality. And lastly, resilience against external challenges, where adaptability in overcoming economic downturns, geopolitical disruption, and global health crisis through a robust maintenance and operational strategy. Moving on to the next case study on OEE. ABB, headquartered in Zurich, Switzerland, is a global technology leader that serves diverse industries with the goal of enabling a sustainable and resource-efficient future. ABB delivers innovative solutions that optimize production processes and energy efficiency. They have introduced OEE as a financial KPI, as OEE is now universally accepted as a significant KPI. ABB highlights the financial impact of optimizing overall equipment effectiveness through its digital solution. By aligning OEE with business objectives, ABB enables organizations to translate operational improvement into a measurable financial gains. As you can see here, they have simulated an OEE of 60%, derived from 77% of availability, 85.7 performance, and 91 quality yield. Through OEE of 60%, the earning profit is 11.286 million, with return of employed capital or ROCE of 6.81%. Then they have simulated OEE increase from 60 to 70 by increasing availability by 6%, performance increase by 6%, and quality increase by 2%. That shows a result of a double profit and return of employed capital. As you can see on the right here, OEE 70% derived from 83% of availability, 91.7% performance, and quality yield of 92%. The profit has increased to 20.663 million with double ROS of 12.25%. With a measured OEE, organization profits become more predictable. So initiatives like reduction in inventory level and demurrage cost can be introduced. In conclusion, TPM methodology and the OEE indicators have evolved since 1960s and now widely implemented across various industries, paving way for a resilient and progressive future. Embedding TPM and OEE into organizational practices has provided clear pathway to, first, alignment with organizational goals, where direct contribution to achieve the company's vision and mission by driving operational excellence, enhancing productivity, and fostering a culture of continuous improvement. Second, improve efficiency and cost optimization by minimizing equipment downtime, improve reliability, and optimize resources. Third, empowered workforce, adding value to human capital, creating proactive culture, increasing skill development that aligns with organizational mission. Fourth, sustainable competitive advantage, higher quality products can be delivered, meeting customers' demand efficiently and maintain competitive edge in the market. And lastly, support for strategic vision. TPM and OEE can act as enablers for long-term strategic goals, driving organizational towards operation excellence, innovation, and sustainable growth. With that, I would like to end my presentation today, and I would like to thank all of you for your attention. Thank you.